Hey everybody, welcome back. It's our first class in April. It's April 4th, 2022. This is Introduction to Statistics, Map 21 at College of the Sequoias. And we just got done finishing up chapter 10 last week, which was on hypothesis tests for one group when we did proportions and we did means. And now we start looking at hypothesis tests for two groups. And we're going to have one for proportion that we're doing today. So 11.1 should be proportions. And that's what we're doing today. Proportion for two sample groups. And then we're going to look at means after we come back from break. Two sample gains. What in the world for two sample groups? Quick recap for you before we dive into that, though, because there is a connection between the two, and I just want to kind of reinforce this as we go down the road. We have our confidence intervals, our CIs. And if I want to put this in words, it's a range of values. Something's in my eye. That is based on sample data. And is likely to include an unknown population parameter. So we went out the error distance around the mean. We got a margin of error. And the width was 2 times the error, and we're like a 95% confidence interval. We're 95% confident the actual population parameter lies in that range, whatever we come up with. And it's based on sample data. If we look at hypothesis tests, after I'm done with recording, I'm going to show you my rigged up lamp settings so that the lighting is good on the paper. It's kind of crazy in here. A hypothesis test is the process for testing a claim based on sample data about an unknown population parameter. And we can see that they're both based on sample data. And they have to deal with an unknown population parameter. And so how are they connected? Well, the hypothesis test, it includes a previous claim or value. To check that we're going to check to see if it's still applicable. And that's our H naught, our null hypothesis. And how does that connect to our confidence interval? Well, is H naught in our confidence interval? That's how they connect. H naught is a previous value, or it's the what we think is the truth, so we have an equal sign for it. And now we come up with a new data set, or we have a new sample data set. We have a new range. And is that old value still in the range? If it's in the range, it's a good chance it's still possibly true. If it's not in the range, then it's unlikely. That's how they end up being connected. Let you have a second to write that down, and then we'll start doing 11.1. Okay. If you need it up longer, just say something and I'll put it back up. Otherwise, I'm going to take it away. So 11.1, it's on a two population proportion test. Okay. And like, remember our requirements for the proportion test? We had some requirements for the one proportion test, and those old requirements still apply. So remember, we needed n times p times 1 minus p to be greater than or equal to 10. And we needed n to be less than or equal to 5% of the population. Those are the old requirements. They still apply, but now we have two groups. So we have two n's and two proportions. We've got an n1 and a p1 for the group 1, and an n2 and a p2. And so this was our one proportion test. When we look at our two proportion test, we got the same thing. We've got double the equations though, because now we've got two n's and p's. So we got n1 p1 times 1 minus p1 needs to be greater than or equal to 10. And n2 times p2 times 1 minus p2 has to be greater than or equal to 10. And both sample groups need to be less than 5% of the population. Now, there's a good, in case they're different populations, like if we count men and women in separate groups, then maybe the populations should be in separate groups too. So we got a big N1 and a big N2. And then the reason we wanted that is we still want both samples sample distributions to look normally distributed. And when we have those situations, then they're approximately normal. So that criteria makes them approximately normal. There's one other thing that we haven't talked about. Now that we've got two populations or two groups, we also want the two sample groups to be independent of each other. And that means that, you know, we don't know connection between group 1 and group 2. So where could we fuck that up? Where could we make a mistake on that? Well, if we're trying to like do a survey on men comparing men and women, like don't go asking a husband and wife or a couple. Husband and wife or any two people in a relationship. I mean, even if we're talking a same-sex relationship, you want the people in each sample to be independent as well. So asking two guys that are a couple to be part of a sample, well, now that they're both going to likely have the same opinion. Not always true, but likely. And so we don't want to include both of them. We just want to do like one of them. So how does this shift from what we had before? What we had before when we did this in Statcrunch, we did stats, proportion stats. We clicked on one sample. Then we had with data, with summary. And we could even do that power sample size one if we need to know the size of the group. And guess what happens here? There's only one change. And now it doesn't say one sample, it now says two sample. We're going to click on the two sample tab. And it has all the same options, same choices. Now H0 is going to be a little bit different. So let's come over here and take a look at it, and then I'll write down what we got going on. So I can go stats, proportion stats, two samples. And let's say we're doing summary. Notice we've got room to enter both results. So that's something that's changed. Oh, I don't want to do that. It takes it off the screen. We need N and X for both groups. Okay. And the other change comes in the hypothesis test. So if you guys are done writing this down, I will move it and put in the new information. If you need it, leave it up. If you need me to leave it up, let me know. I'll put it back up. So Statcrunch asks for P1 minus P2 equal to 0. Notice 0's got a box. And that's our H0. And HA, the thing that has a box here, is of course the sign. All right, we're going to do not equal, and then we've got 0. So two things going on. First off, we've got two populations, P1 and P2. Where they get P1 minus P2 equals 0, P1, if we had P1 equal to P2, like we suspect both populations have the same value. That's what happens when we got P1 equals P2. If I subtract P2 from both sides, I get P1 minus P2 equals 0. Now, that's when we suspect they both have the same value. That's why they put it this way, because the next question makes it a little bit easier to edit this value. Well, like let's say P1, suppose P1 is for men and P2 is for women. And we're talking about the proportion in the group taller than 5'7". Now, men in general have a taller height. The average male is taller than the average female. There are variations. There are women that are much taller than me, and there are men much shorter than the average woman. But in overall, the average male is taller than the average woman. So P1 shouldn't equal P2. P1 should be bigger. We would have P1 is bigger than P2. And if I did the same process of subtracting, I would have P1 minus P2 is greater than 0. Now, what if I wanted to say they're not just one's greater than the other, but what if I wanted to say it's like they're like 3 inches taller? The average male we think is 3 inches taller. If I wanted to change this to say men are 3 inches taller, I could make this a 3. And now if we're talking about the height in inches, then it works. The difference should be greater than 3 inches. So that's the idea of why we have that 0 there. We can make it so that there's a bigger separation. So the box around it means we can make the difference between the two groups greater than 0. And for just that reason, when we want to say it's a lot bigger than, not just bigger than, like it is known the average male is taller than the average female. This is statistical fact. But is the average man 3 inches taller? I don't know. That's a different question. That'd be a good study thing. So I've got some pro tips for you when you're going through this. Pro tips. Notice right here, when I said P1 is men and P2 are women, I labeled them. But I'm not even going to make that the first pro tip. First pro tip, read the problem a couple times until you understand what's going on, what's being asked. If you get to a problem in the homework and you're like, I don't even know what they're talking about, I don't know what that is, maybe Google the idea, see what they're talking about, so you can get an idea of what it is they're talking about. Because if you have no clue what they're talking about, like if you grew up in the 30s, 40s, when we had telephones that were only landlines, and I started telling you about 5G cell phone service, you're going to be like, what the hell is a cell phone? What's 5G? Shit, I don't even know what 5G means. I just know it's bigger than better than 4G, presumably. I don't even know what it means. So like if I don't know what it means, and I think I need to I don't know what a cell phone is, and the problems about cell phones, maybe I should look up what a cell phone is. Thankfully, you guys grew up in a world where Google exists, search engines exist. When I was a kid, hell, when I was a teenager in high school, there was no internet. It was definitely go to the library and grab an encyclopedia. It sucked butt big time. So make sure you know what the problem's asking. Then identify and label your two groups. And write down the traits that go with it. Write down stuff you need to know. Write down important stuff. I know I need like a population or a proportion is X over N. So I need to do a proportion test. I need an X and an N for each group. So I need an X1 and an N1 and an X2 and an N2. Maybe write down what those values are. But definitely label your group. Okay. I recommend doing what I did right here, setting them equal and going like, okay, what is the problem asking? Start with P1 equals P2 and choose the numbers such that you get it the way you want it. Like if the question is, they think men are 3 inches taller than women, this thing requires P1 minus P2 in that order. I don't have an option of changing it. Okay. So if I said men were group 2 and women are group 1, what does men are 3 inches taller mean when I get to this thing? What symbol do I use? That's confusing. Okay. That's why I'm telling you to label it. In fact, I would go so far as to say, if you need to, put on a scratch paper, men are, I hate saying this, greater than women. God, that sounds like a terrible thing to say. In terms of height, men height is greater than women height. And then when you do this subtraction thing, it makes sense. Move them all to the left side. So I'd have men minus women is greater than 0. Do that here. And I recommend if it's a greater than or one is less than the other, like whatever group they're talking about, write it so like the symbols match the wording, because I'll show you the two. Well, hell, we'll do it. I'll do it in an example. I'll show you the difference when we do our first example. I recommend doing it like this. Do it that way. And you'll see why in a second. And then 3, make sure you write down, identify alpha while you're looking at the text and you know where to find it. Write all that crap down. And then we're going to do some sample problems from the notes. Then we'll do one from the homework. And I know we'll be done early today. I'll tell you a little bit about the project. I'll show you where to find the information. Any questions? Okay. Let's go on to looking at an example. So I'm in those lecture notes I was telling you about. And yeah, let's just do this one. We'll start with this one. We'll do a couple. So this is from one of the pages in the book, or the lecture note things that we have in Canvas. I showed you the other day. This is page 123 in the Math 21 lecture notes document. Doc in Canvas. So let's just write down, talk about what it says. It says an economist believes that the percentage of urban households with internet access is greater than the percentage of rural households with internet access. So I'm gonna what is that? I'm gonna summarize that sentence. And I can come back and fill it in later. But I see urban. They're both talking about with internet access, so I'll add that in later. But it says, if I take out that part, it says urban households is greater than rural households. Oh my gosh, I have the hardest time saying the word rural. 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 It just sounds funny in my voice. In fact, I'm not going to say rural. See, I can't do it. I'm going to say country. Country homes. You know, out in the country, where the people live further apart. I can say country just fine. I'm going to use country. That's what it says there. And then it starts giving me stuff. So let's just start writing down what we got. It says he obtains a random sample of 800 urban. So let me just start writing down urban data. Urban data, we have N is 800. That's our sample size. And 338 have access. Since we're doing a proportion, that's probably our X. And then it says he obtains a simple random sample of 750 rural country households. So N equals 750 for this group. And 292 said they have access. So I'll write that down. And it says alpha is 0.05 level of significance. So I'm going to jot that down. Okay. Give you a second to do that before I take the notes on the right off the screen to look at Statcrunch. Okay. So I'll re-show you how to get there. We're doing stats, proportion stats, to sample, and since we don't have a bunch of like a data table, we're going to do summary. Now it tells me I need sample 1 and I need sample 2, and I need to pick, so I need to pick them. And if I leave this the way it is, I can treat urban, I could call my urban group as P1, and I can call my country group as P2, and I'll have that symbol. So that when I subtract the P2 from both sides, I get P1 minus P2 is greater than 0. And now I know all my urban data is P1, all my country data is P2. So when it's asking me for what goes into sample groups, this is sample 1. And this will be my sample 2. Now, this is what the sentence said, and this is when we translate it out, this is what we get. That must be my HA, because it doesn't have the equal sign. So the H naught is going to be P1 minus P2 equals 0. That'll be H naught. And I'll rewrite them right here to put them in the correct order. And now I know what I'm looking for here. Because that's step one in the hypothesis test, right? That's step one. Identify H naught and HA. Step 2 and 3 is find alpha and find the test statistic and p-value. Well, Statcrunch will give us that. So I got my sample information here. Sample 1 was the group on the left. I'm going to put that in sample 1's group. And I'll put their 800 there. And then sample 2 is 750. I'm using tab to get through the box between the boxes. The tab key makes it so you don't have to use the mouse and click on it. And they have 292. And now that I've got it written out, I actually know what I need to click here. It's not like a mystery. Oh, I wrote this in the wrong order. Look at that. Not paying attention. And it told me I got them in the wrong order. That was convenient. Good looking out, Statcrunch. All right, so I can confirm my H1 or H naught and HA look like it should. And this is what I'm looking for. So step 2 and 3 is identify my values. I've got Z-stat is 1.3286. P-value is 0.092. And I already have alpha written down up here. Alpha is 0.05. So this is like step 2 and this is step 3, but it can go in either order at this point. But we need both of those pieces of information for step 4. Step 4 is make a decision, which means we got to compare our p-value and alpha. And thankfully, again, that hasn't changed from our one sample thing. The only thing that's really changed is step 1. What does H naught HA look like? So I'll compare my p-value and alpha. P-value is 0.092. Alpha is 0.05. P-value is bigger than alpha. So let's see, p-val's too low, reject the null, or the null must go, but the p-val's not too low, so the null must not go. The null's got to stick around, so we're not going to reject it. Do not reject H naught. And do not support HA. And remember, I tend to write DNR, DNS for do not reject and do not support. But I saw that we have a classmate here that's not here all the time. Melissa, hi, welcome. And so I thought I would recap it or use the full word. All right, so step 5, make a conclusion statement that goes along with this. And remember, the conclusion statement's about whatever we're going along with HA. So I'm going to come over and come back to the original problem and look at what HA was. HA was a sentence in the first part right here. An economist believes that the percentage of urban households with internet access is greater than the percentage of rural country households. So we don't have enough evidence to support it. There is insufficient evidence to support the claim. And if I want to be, don't want to reword it, guess what? I can like almost, as long as it makes sense when I write it out, I can copy and paste what they have there. Well, I can't copy and paste it because I'm writing it, but I can fill it in. There is insufficient evidence to support the claim that the percentage of urban households with internet, I'm going to say web access, just to shorten the words a little bit, is greater than the percentage of rural country I'll use the word they use just because I can't say it out loud very well. Doesn't mean I can't write it. So I'll leave that up for there for a little bit, let you write it down. We're going to do this exact same problem again, and I'm going to switch around which one's group 1 and which one's group 2. And I want you to see how the results change and why it's important to label things. All right, if you need it up longer, let me know now before I take it away. Okay. So I'll just recap what we had there. First run through, we had P1 was urban, P2 was country or rural, HA was P1 minus P2 was greater than 0. And my p-value was 0.092. And my z-stat is 1.3286. And we went with DNR. Do not reject, do not support. Do not reject H0, do not support HA. What happens if I switch this around? So now I'm going to say P1 is country and P2 is urban. Now, the first thing that I really need to note is I need to make sure I put the right data with the right group. So urban was 338. And that was my X and 800 for N. And P1 had 292 for X and it had 750 for N. So that's X, that's N, that's X, that's N. Now the sentence said, gotta look at it while I read this. The percentage of urban households with internet access is greater than the percentage of rural. And I need to make sure I have P1 on the left and P2 on the right. So I kind of have to like write country first, urban second, to go with P1 and P2. And now when we're looking at greater, well, like the greater symbol is this, but that's not really what we want it to, that doesn't apply here. It's not correct. Because the greater number, the larger number, the alligator should be going after the larger number. So if I make an alligator, or better yet, vampire. Vampire coming. Vampire's coming for the prime piece of meat. Person with the extra fruity blood. So if I subtract, I want everything on the left. If I subtract it over, I get P1 minus P2 is less than 0. Okay, so I'm going to go through and enter that. I'll do it in a new box. We'll leave that down there right now. I'll do stats, proportion stats, to sample with summary. And now I got to make sure I do it right. The country is my P1 group. So 292 goes there and 750 goes there. And my population 2 group is urban, and that was 338 here and 800 here. And now I got to make sure I go with the less than sign. And if I do that, well, my z-stat changes. Look at that. My z-stat's now negative. In fact, it's the exact same thing, but negative sign, right? Look at those two values, one right over the other. The only difference is one is positive, one is negative. P-values thankfully stayed the same. So all my later steps still work. My comparison, my do not reject, do not support, all gets backed, and I can do everything correctly. But notice that the sign changed and my z-stat changed. So you need to have them labeled, because first off, the result actually changed. It's not the same result. Furthermore, if you do the wrong thing, I'll show you. We'll do a third set. I'm going to put that stuff in the same order I just had it, 292 and 750. And I'll do 338, 800. But what if I put that in and I don't have my things labeled and I read the sentence and the sentence says greater, so I go with the greater than symbol here, which is not correct. Look what happens. The z-stat stayed the same. The p-value is a lot different. So if I mess up and use the wrong symbol, in this case, putting P1 minus P2 is greater than 0 when it shouldn't have, my p-value is 0.908, which looks a lot like the 0.92 down here because there's a 9 and a 0, but like it's not. Thankfully, in this circumstance, it didn't mess up my outcome, because this would still be a do not reject, do not reject H0, do not support HA. In this case, in scenarios, let me see if I can adjust this problem. I showed that. I want to adjust this to see if I can get it to show a p-value that says rejected. So I'm going to edit this and let's see. I'm going to make this, I don't know, let's go with 312. Would that give me a p-value that's, nope, that went the other way. So let me make that like 270. I want a p-value that's low. There we go. If I had a p-value, if I use country X equals 270, not 292. The p-value should be 0.05, which is less than alpha. And this would be a reject H0, support HA. So that would give us that situation. Let me tinker with the other one and show what happens when we alter it. Like that's the one that didn't work. Let me show that this one still gets the same result. I'll put that to 270. And my p-value is 0.059 again. And now look what happens. This is the one where I had the wrong symbol. If I put it here, the wrong symbol when X is 270 on this one. For country. My p-value is 0.9941. And this is definitely greater than 0.05. So this would be a do not reject H0, do not support HA. When the correct answer should have been, if in that circumstance, when the correct decision is this, and you end up getting this because you have the wrong sign, you have completely just ruined the experiment. And it would all be because you didn't label it. That's generally the only time you're going to make that mistake. If you label it and take the time, you write the stuff out, not just speed race to put stuff in the computer. Make sure you understand what you're putting in and why it's going where. Good things happen. Okay. There was something else I should have done with this problem and I didn't do it. And I regret not doing it. So we're going to go back and do it right now. So back to the original problem. For urban, I'm just rewriting down what I had. Urban, we had 338 for X, and we had 800 for N. And for the country population, we had 292 was X, and I need to put the variable in front. That's driving me crazy. And the 750. So the hypothesis test doesn't change. What we did was still right. What I didn't do, and I should have, is we need to check to make sure these are normally distributed. Because this test doesn't work if they're not. So I had called this initially P1 and P2. And we need N times P1 times 1 minus P1 to be greater than or equal to 10. And we need the same thing for P2 with N2. So in this circumstance, well, let's figure out what P1 and P2 are. P1 is 338 over 800. So P1 is 0.4225. And we'll do the same thing for P2, 292 divided by 750. And I'm getting 0.389 and then a bunch of 3s. 3 keeps repeating. All right, let's go through and do our test. P1, I had n was 800. So I have 800 times 0.4225. That's my n1 times P1. And then I need to do 1 minus P1. 1 minus 0.4225. I need to do this calculation and make sure that it's greater than or equal to 10. So I'm just going to put that bad boy in my calculator exactly as I see it. I see 800 times 0.4225 times, and then I need parentheses, 1 minus 0.4225, and then I'll end parentheses. And that's everything, and I'll hit equal. So what am I getting there? 195.19. That's a crazy number. So I'm getting 195.195. And we're trying to check to see, is that greater than or equal to 10? Yes. Now we'll do the same thing with the other group. I've got N2 is 750. P2 is 0.3893. And this is 1 minus 0.3893. It really is the repeating thing, but there's no real way to doing that if I just put the decimal in. But this should be close enough. 4 decimal places should be close enough. Because I'm not entering in the computer, I'm just checking sure it's bigger than 10. 750 times 0.3893 times parentheses 1 minus 0.3893. And I'm getting, is that 178? Yeah. 178.3. Is that bigger than or equal to 10? The decimal points don't really matter. 178 is definitely bigger than 10. So yes, this one works also. And then finally, N2 is the sample size less than 5% of the population. Well, I got to assume there's more than 800 urban homes. I know there is in Tulare alone. There's more than 800. There's a lot more than 800. But if we're gonna go like maybe like if I want it 5%, I don't know if it's 5% Tulare. It might be. Let's say this is in Fresno or Visalia. Visalia, I know it is. It's got to be with Tulare. It's got to be. Same thing with the P2. It's definitely going to be less than 5% of the population of country homes, especially if we look at all of the country, not just, the city. So both of the criteria is met and we can do the test. Okay. And I'm going to do one last look at this and with the confidence intervals. So which one was this? I want to close the 2. I want to go with the initial one, which is this one right here. P1 minus P2, and I'm going to put that back where it said 292. Let's look at the confidence interval. We already concluded this was a do not reject. I guess I can put that here. Final thing. Before we look at a homework problem. So we had our p-value was 0.092. And we went with do not support HA. And which also is do not reject H naught. How does the confidence interval match up? Okay, so when we have a greater than sign here, tells me that this is a one-tailed test, which means alpha 1 minus alpha times 100 gives me my confidence interval percentage. 1 minus 0.05 is 0.95. I multiply by 100 and I get 95%. So I'm comparing this to a 95% confidence interval. And my lower bound is I'll do 3 decimal places, negative 0.016. My upper bound is 0.082. And if I put this on a number line, I now want to look and go, where is H naught? So if we go back and look at H naught was P1 minus P2 equals 0. Where is 0? Well, 0 is in between these. It's a little bit closer to the negative one, but 0 is right here. So H naught is inside the CI, inside our confidence interval, and that's why we don't reject it. We don't reject it because it's possible. It's sitting right there in the box. So that's why we don't want to reject it. And that's another look at how confidence intervals and hypothesis tests that we've been doing match up. You can see how they relate. Any questions? All right, let's come take a look at the homework and do one of the problems in here with you. All right, let me make that bigger. That doesn't make the text any bigger. Let me see if I can make the text bigger so it's readable. There we go. And again, is it still readable if I do this? Nope. There we go. So researchers wondered if there's a difference between males and females in regard to some common annoyances. They asked a random sample of males and females the following question. Are you annoyed by people who repeatedly check their mobile phones while having an in-person conversation? Does that bother you guys? And you're sitting there talking to someone face to face and they're checking their phone, ignoring you. If they do it like once or twice, like they get a text and like and they're waiting for an emergency, yeah, okay. But otherwise, it's like, dude, what the fuck? Do you not give a shit what I'm saying? Are you so like in your own world that you don't even care that I'm talking to you? Yeah, that drives me crazy too. So they asked, it looks like they asked males and females. So I'm just going to write that down here. So I don't know what I'm going to call group 1 and group 2 yet, but they asked males and females. So I'm going to record their number of results they've got. And they asked them the following question. Among the 515 males, so N was 515 for the males, 189, which be our X, said yes. And we look at our females and we've got N equals 563, the number of people surveyed. And the number of people that responded yes, 218, that must be our X. So now the question is, does the evidence suggest higher proportion of females? Okay, so with that in mind, like I'm gonna write this down because like I need to see it. I can't just drop in P1 and P2 and hope I'm gonna be right. So a higher proportion means that females have a larger number than males. The female proportion for so P for females should be bigger than P for males. And so if I want everything on the left, I'm going to have P for females minus P for males is greater than 0. So even though they talked about men first, I'm going to label group 1 is female. And group 2 is going to be male. Because the higher than thing works like it makes sense to me here. If I put the men first and the female second, this is going to be the wrong symbol. And looking at a less than symbol and thinking higher just does not work for my brain. If it works for your brain, go for it. But for me, I kind of need it this way. So I'm going to do it this way. And so this must be my HA. And that's my H naught. So P1 is females minus P2 for males equals 0. And then P1 minus P2 is greater than 0 for HA. So I let the sentences guide how I pick the groups so that it makes it easier to enter on Statcrunch. And I got to come over here to Statcrunch and start plugging some stuff in. So I'm going to go stats, proportion stats. They didn't give me a data table, so I got to do with summary again. And let's see, I labeled females group 1, so this will be 1, that will be 2. Labeling all this stuff helps me figure out where I'm going to put what. The female information goes on top. The male information goes on bottom. And I can get all my symbols to match up what I'm doing on the paper. And I click compute. And okay, well, this was step 1 right here. Step 2 is writing down my z-stat is 0.6841. And my p-value is 0.247. And I don't think I need Statcrunch anymore, but I'll leave it up. Ah, shoot. There we go. Put that back down, smaller size. I want to read the questions. So maybe I'll shrink that down a little bit more. There you go. Determine the sample. Oh shit, I should have read the damn instructions. Well, let me finish the hypothesis test reasoning over here, and then we'll fill in what we need to in a second. Step 3, they don't give me a level of significance. Do you guys see alpha anywhere? I don't see an alpha. So step 3, alpha, I don't know. And if you don't know, make it equal to 0.05. Step 4, I will compare. Is p-value greater than alpha? Is that the case? Because if it is, remember, if the p-value is greater than alpha, we reject H naught, support HA. And if it's less than or equal to alpha, I said that backwards. Is p-value less than alpha? And is p-value greater than or equal to alpha? There we go. If p-value is less than alpha, we reject H naught. If it's greater than or equal to, we do not reject H naught. And we do not support HA. So let's look at our actual values. My p-value here is 0.247. My alpha is right here. It's 0.05. 247 is bigger than 050. The number on the left is bigger. It looks like I'm in that category right there. P-value is larger than alpha. And so step 5, I want to make a statement. And I'm going to say there is insufficient evidence because I'm not supporting HA. That. And what is HA? HA is females are greater than males. So I'm coming back up to look what I wrote down. And I'm going to kind of try to put it in words I see here. There's insufficient evidence to support the claim that a higher proportion of females are annoyed. And I'm not going to say by this behavior because I don't know what the behavior is with that thing. I'm going to come up here by commenting on what it is up here. A higher proportion of females are annoyed by people checking their phones in mid-conversation. During an in-person or face-to-face conversation. I'm going to say face-to-face. And face-to-face sounds wrong. Maybe that's A. Is that A? Doesn't. I thought it was and. Yeah, we use AN when it's a vowel. It is a face during a face-to-face. The in-person had the and. That makes sense. All right, so I'm probably going to need that in a second, but that's not where they asked us to begin with. They want the proportion of females and males respectively. So I can figure that out up here. We got our info up here. I need to do 189 over 515 for males. I need to do 218 over 563 for females. And I can see they want 4 decimal places right there. And they want females first. So I'm going to calculate females first. I'll do the females first. 218 divided by 563 equals to 4 decimal places, 3872. And if I do the min, I'm getting 0.36699 is 70. Look at that. 36699. And now I know what I need to enter here. Oh shit, I already wrote it wrong. Females go first. 3872 and 3670. We'll check answer. Explain why this study can be used to analyze, explain why this study can be analyzed using the methods for conducting a hypothesis test regarding two independent proportions. Select all that apply. Well, I know the sample size is less than 5% of the population size for each sample. That's got to be true. They said they asked a random sample of males and females, so they should be independent. And we're supposed to check that N1 and P1. It's, you know what? I still didn't do it. So let's do that right now. So I'll do that right here. My N1 is females is 563. And I have my P1 right there is 0.3872. And I'm just writing these down so I can get rid of the other pages in my way. So that was males and females. I've got my information. And come take a look at this. N1 P1 times 1 minus P1. What do we get when we do that? 563 times 0.3872 times 1 minus 0.3872. Now, if your calculator doesn't have a parentheses sign, I think it might be easier to start with this one and just write it down. So I'm going to show you how I would go about this if I don't have that going on. I'm going to do that 1 minus 0.3872 first. And I get 0.6128. I'm going to write that down. And now I can multiply them all normally. Just do multiply straight across. That's 133.6. And that's definitely greater than 10. Bam. We'll check N2, P2. N2 times P2 times 1 minus P2. 515 times 0.3670 times 1 minus 0.3670. And again, I'll do that sub-step where if you don't have parentheses, it's good to do. I mean 0.633. And now I'll multiply them all out. $119.6. That's also greater than 10. So I met those requirements. And that looks like all the samples are dependent. We don't want that. We want samples to be independent. It says the data comes from a population that is normally distributed. I have no idea if liking self or being annoyed by cell phone usage during this conversation is normally distributed. Not for men, not for women, not for the population in general. I have no idea. So that doesn't apply. And in fact, that's why we just did these tests. We don't know that they're normally distributed, but samples like this should be. This says the sample size is more than 5%. That's exactly what we don't want. We want it less than 5%, which is A. So we don't want F. So it should be A, B, and C. Oh, good. Now they're back to the hypothesis. So I'm going to come back and put that back up there. And it says, oh, good, they chose P1 to be females also. What are the null and alternate hypothesis? Let P1 represent the population proportion of females. That's what we have. So theirs should be exactly set up the same as mine. P1 should be equal to P2 for the base case, and P1 should be greater than P2, just like I got written right here. The equal sign is always there for the H naught, but I got females are greater than males, so that's what's I'm going to put there. Describe the sampling distribution of female minus male. Well, it should be normal because that's what we just did these tests for. The test we did on the other page should be normal, approximately normal. That is the only option on there. Why does it say describe the sampling distribution if they're going to do it for me? The sampling distribution is approximately normal with mean and standard deviation. Ooh, I didn't calculate that, so I need to do some calculations. So what are the equations? Oh God, we don't want to do this by hand. Let's come over and look at Statcrunch. It should give us the mean and standard deviation. The mean should be that. What a crappy question. Well, that's a sample difference. I'm going to put that. And standard error is usually the deviation. All right, let's come over here and do that. Oh, not there, here. It says the 4 decimal places. I've got that, can't be right. P1 minus P2. That's what they're telling me I did that wrong. So the mean is P1 minus P2. We have P1 and P2. P1 is 0.3872. P2 is 0. That should be what I had. I'm going to subtract them. I got, I wrote a 6. That should be a 2. 2020. Now what I put? How is that wrong? Maybe since I rounded? No, I don't know. Let's see, let's go back to the original. So the original was P1 was 218 divided by 563. That's my P1. In fact, let me put that in parentheses. 218 divided by 563 was my P1. And I'm going to say minus P2 is 189 divided by 515. And it's still 0202. There is no rounding error. Did I use a comma? I don't know. Let me retype it. 0.0202. They got a glitch. Did I write down that 218 divided by 563 wrong? Nope. That's right. That value is right. And that value is right also. So maybe I used the wrong number somewhere. I've got 515 and 189. I see those right here. And I've got 563 and 218. Nope, computer's got a mistake. That's annoying. All right, what's this question asking me here? That's too small. So draw a normal model with the area representing the p-value shaded for this hypothesis test. So my p-value was 0.247. It's not my p-value. Why are you calling it p-value? Oh, the p-value is shaded. So we're looking at our P1 minus P2. That was our 0.2. You know, look at that. They've even got 0.0202 right here on the graph. That is so rude. We just need to shade it the right way. Shading it the right way would be shading greater than it. So we want to show that it's greater than it, and that would be where it's shaded to the right. Determine the p-value. We did that already. I'm not redoing that. We got 0.247. Round to 2 decimal places, you tricky bitches. Quit changing the number. Oh, hell no. Oh, first find the test statistic. It says determine the p-value. So I read that and then I stopped reading. First find the test statistic. The test statistic we had, that's my z-stat right here. That's 0.86. Why do they say one thing and then they change the question on the entry field? They're like, do you have the time and the patience to read every word on the page? Oh, hell no. I know it's right. We just did it. Oh shit, did I transpose it? I might have transposed it. Ha! I did. I wrote it backwards. I wrote 8641. It should have been 6841. Oh, my bad. I guess I should have relooked at it when it said I was still wrong. Oh, that's terrible. Oh, well. There's my p-value question. And now they want 3 decimal places. 247. Okay. If the population proportions are the same, we're looking at H0 here. One would expect a sample difference proportion greater than the absolute value of. You don't really need it because it's positive here, but we're going to say absolute value of. Then the one observed in about how many out of 1,000? We got to multiply this by 1,000 and it should be 247. Move the decimal place 3 times. Or you wanted me to just say greater than? Yeah. Based on the p-value, what does the sample evidence suggest? Oh, now they give me the alpha. The alpha is 0.01. That doesn't change my answer. that would 0.247 is still greater than 0.01. So we're gonna do not reject H0 and do not support HA. So let's see, the ones that say do not reject H0 are the top two. And since I'm not supporting HA, I need to say there's not enough evidence. There is not sufficient evidence. So we're going to go with B. And that's it. That's kind of like what you can expect on the homework and stuff. Yes, the computer does have errors in it, as we saw. And yes, it's easy to make errors, even when you're a teacher and you know what the hell you're doing. So it's always worth checking your work and write the stuff out. In terms of your project, let's come over. And are there any questions about 11.1? I keep sliding out my chair. No, nothing in chat. Okay. So if you want to find out about your project, you can come over to the announcements. And I've linked stuff about it. So let's make this big screen. You now have the required stuff to do 7 of the 9 parts. The beginning parts are like stuff from the beginning of the semester. Your project is written in Word. You can download it. And if you don't have Word on your own, you can go into, you can log in here. You can go into Office 365. And every student has access to this stuff, and Word is over here. It'll give me an online version of Word. I can say new blank document and just copy and paste the whole thing into this and edit it and save it in your office space. Once you have it all done, so let me write, I can type it here. Once you've done, oh, let's do this where it's readable. Once you've done the whole project here, or on Word regularly, if you've got Word on your computer. Well, you don't need to do it if you got a regular Word. If you got the whole project here, up here, you should be able to click File and Save As. And say download a copy. You can download it as Word or download it as a PDF. I'm good with either. I don't know what ODT is. Don't do that one. Either download a copy or download a PDF. So what was the steps? File, save as. Go to File, save as. And then download Word or download a PDF. And just save it on your computer, because then you'll come back here and there's another link to where you can submit it. For you, it'll actually have a box that says submit. Let me show student view real quick. They'll say start assignment. You click start assignment. You say choose file wherever you've got it saved. Let's say it's in your download. And you upload your download. Say open and click submit. You can do the Office 365, but I got to tell you, it's a pain in the ass to grade that way. And so you can do it, but I'm going to be annoyed when I'm grading it. And that's, I try to be fair, but it's how fair can you possibly be? Like everyone's going to be like influenced by their own mood. So you're better off trying to do the PDF Docker Docs, and I will do my best to be fair when I'm doing Office 365. I hope I'm fair, but I know I'm fair when it's the Word or something like that. I can grade both as long as I know where it's at. Don't, I think it's in, I'd rather you didn't do that though. Let's see. So, and then if you want some video stuff on how to do it, you can click, I did it last semester. It's about 15 minutes. Let's go take a look at this real quick though. I wanted to show something. The first steps, you're gonna want to, the survey you don't need to take, you just gotta hop in here and click on the stats project, and it will open up the data set. Now, a student emailed me today, and so I'm going to show it here. Part C asks for stuff from the summary stats. So I don't know which column, I don't remember which column I had the summary stats question on. I doubt it was age, so I'm just going to grab age and show it real quick. I'll click mean, standard deviation. Maybe I'll do my 5-number summary, my min, Q1, median, Q3, and max. Maybe I'll throw in the interquartile range. I'll click compute. Now, when you try to, the other stuff, it shows you how to download just fine. The stuff in the stats, summary stats, it's easier to highlight it all and then do the control key plus C. If I try to right click it and say copy it, it might give me a problem, but control C works. And then when you go over to put it in Word, let me come back over here. I can put it in Word by doing control V. So control key, which is the CTRL key, plus C copies, and CTRL plus V paste. So I copied and pasted it here. You can edit the thickness so it looks a little bit better, like the standard deviation and mean probably should show their whole thing without being all squishy. So let me like make some of the other ones shorter so I can make that longer. There we go. Oh, that looks tacky. There we go. Look at that. Now it looks better. So you can edit the lines by just putting your cursor over the lines, and it turns into that double line. You can drag it through it. The general file gives you tips on what you should do in the beginning. So you do not skip over this, like read this shit. It'll give you tips. Here's the questions, just so you know what they are. Notice that when I asked people their heights, some people did it both ways. They didn't convert. They were supposed to put their conversion or feet in inches. So on the data set, where's my data set? So like the 5'9", that's 5'9". They shouldn't have put 5'9". They should have done, convert the 5 feet to inches. 5 feet in inches is 60 inches. This should have been 69. So I'm going to type over it and put 69. I'm guessing this person thought they were doing the 5 foot. They converted it to 60. And then they wanted to do the 2 inches. They kind of combined the method. This should probably be 62. And so you're going to want to go through and look for anomalies like that. 71.5 is probably them saying that 1/2 inch. So that's fine. 5.07, it's probably 5'7" inches. And if you don't remember how to do it, the document explains to you, where did it go? The document explains to you how to go about converting it. So I would make those conversions. I gave you the data the way it came because that's how it happens in real life. People don't always do what you want. They don't always give you the answers the way you want it. So you have to go through and tinker with the data, and make it so it all fits. So I'm just allowing you to simulate a real life experience there. Look at that. Once you go through it, you'll have questions. There are some preliminary questions before you start doing anything. Just like make a conjecture, read the problem, what the question's about, and make some, what do you think the results are going to be? And you'll go through and do like talk about stuff we've done throughout the semester. Okay. Any questions? All right, we'll call that a wrap. If you got no questions, you may have a good day. Wednesday, I'd rather you work on homework and start working on your project, or if your schedule permits, start enjoying your spring break early. We will not have class on Wednesday. I will be here on Wednesday from 2 to 4 to answer any questions you've got. So if you happen to start your project before then and you want to ask questions, stop by from 2 to 4 this Wednesday. I know I'm going somewhere over spring break, probably midweek, because my birthday is on the Wednesday in the middle of the week. We might go somewhere. We might go out, drive out to the beach, but I will be answering emails most of the time over spring break as well. So if you've got questions over spring break, you can email me then as well. Whatever you do, don't take spring break off. Most students do. They don't do any homework over spring break. They don't do any work. And they come back after 10 days of relaxation and they don't remember a goddamn thing what they were doing. They don't remember anything. And I know I did the same thing when I was a student until I figured out, nope, don't do that. As long as you keep doing a little bit of work each day, you'll keep the stuff fresh. That's my pro tips for spring break. Other than that, have a good spring break. Come see me on Wednesday if you got questions, and peace out. Thank you, Gabe.